You can do an example here where now what we have is we have the situation where we've got 6 flasks. Each of them contains 200 milliliters of a solution that contains benzene at 250 milligrams per liter. We have an additional flask shown here that contains benzene but no carbon. So this is our control or our blank. And you're asked then to take this data and analyze it so that you can plot the Freundlich and Langmuir isotherm. So looking at the data here, we start with a volume of 200 milliliters, and C naught is 250 milligrams per liter. So looking at the first flask, we have 0.2 liters times, we start with 250 milligrams per liter. We have 4.7 milligrams per liter, and that is 49.06 milligrams that has sorbed. So this is the mass of benzene that is sorbed. So if we take 49.06 divided by 0.804 grams, so this is milligrams, this is grams, that is 61.02 milligrams of benzene per gram of activated carbon. We can do the same sets of calculations for the others. So for instance, here we have 0.2 times 250 minus 7. And this is liters, this is milligrams per liter. We'll divide that by 0.668 grams, and that is 72.75 milligrams of benzene per gram of activated carbon. Similar sets of calculations here, and we would have 94.02, and that's milligrams per gram. And we have that. So we can plot X over M versus C sub V. We have a nonlinear plot. We can then plot in this case, it's the natural log of X over M versus the natural log of the equilibrium concentration. Notice we have a straight line here. So we've linearized the data. We now have an equation. We've got an R squared, and we can determine the log of K is our y-intercept here. And we take then 10 to the 1.57, and that gives us K. The slope is the 1 over n, so this is our 1 over n. And we can write an equilibrium expression. So this is the Freundlich isotherm for the data that we obtained. We can do the same for a Langmuir isotherm. Again, we're linearizing the data, in this case by 1 over X over M versus 1 over the concentration. This is our Langmuir isotherm. So we linearized it in this way here. And we have an equation for a line. So this is 1 over AK. This is 1 over A. This is 1 over X over M. This is 1 over C sub E. So we determine 1 over A. We can determine A. 1 over A times K. So we have K. And we can determine then a Langmuir isotherm. So we'll end there. Happy to answer any questions. And on Wednesday, we'll start some examples looking at how to apply this in an engineered system. Any questions?